Good morning out there, everybody. Welcome to OpenCV Weekly Webinar episode 47, if you can believe it.
Wow.
Yeah, we're coming up on 50. We got to figure out something cool to do. Yeah. Greetings from San Francisco, everybody. If you're joining us in the Zoom or on LinkedIn or Twitch or Twitter or Facebook or YouTube, go ahead and say hi in the various chat services and tell us where you're coming from. We always like to see it.
And we'll just wait for a minute or so so that people get a chance to join in. I'm here from San Diego, and we also have Sergio with us from Spain.
That's right. Good morning, Detroit. Good morning again, Torino, Italy. Boston, Quebec. United Kingdom, Paris. Hello again, Toronto, Vienna, Germany, India, Texas, Copenhagen, Mississauga, another fine Ontarian town, I assume. It's going to be a fun one. Sergio has been one of the folks posting some of the best social media content, I think, for this competition. I picked a great Lego set. I liked the most recent one, testing out the six-wheel drive. That was fun.
I also want to take a moment to, people who are affected by the war between Russia and Ukraine. My heart goes out to all the people. We have friends on both sides. As many of you would know, that the OpenCV team is actually at Intel. Part of the OpenCV team is in Russia. Both OpenCV.org, which is the nonprofit foundation, and OpenCV.ai, which is the for-profit one. The Intel team that maintains the OpenCV library is also in Russia. And although they are not as affected as people in Ukraine, but these people, they are all anti-war. And this is just amazing how one person can completely, hold the world hostage with this war. And of course, the Ukrainians, we have a team in Ukraine as well, which helps us with the course part. And they are very, they are disrupted also. It is heartbreaking. I don't know even what to say about the situation. Just hope and pray that this war is over soon. At least a ceasefire should happen soon.
Yes, we all hope for peace. There's nothing that can be gained from war here. Nothing at all.
All right. So let's get started. Hello, everybody. Welcome to OpenCV Weekly Webinar. And today we have with us Sergio Valme, who is one of the contestants in OpenCV Spatial AI competition sponsored by Intel and Microsoft Azure. And if people do not know about this contest, it was launched a couple of months back, where the idea is that you use OAK-D Lite, which is one of the spatial AI cameras, OpenCV AI kit, with depth, so it can do depth estimation as well as neural inference in real time. But the catch was that you also had to build a manufacturing plant or some manufacturing service using Lego sets. So you use Legos to build some kind of factory setup, which is almost real, not 100% real, but still in the Lego world, it is real. And you use the spatial AI camera to do spatial AI. And one of the contestants, Sergio, is one of the contestants who has been entertaining us a lot on social media with regular updates. So I'm so excited to see what you have built so far. And we will see the process, how he has built it and what he has built so far. Also with us is Phil Nelson, who is the content manager at OpenCV. And Phil is responsible for putting together the webinar and a ton of other stuff at OpenCV.org. Welcome, Phil.
Yeah, good morning out there, everybody. It's me again, the co-host with the co-most, the second banana who is second to none. Welcome back to OpenCV Weekly Webinar. This week, like every week, we've got a couple of things that we do. One is we take Q&A from you in the Zoom audience, so please use the little button at the bottom of your screen to ask your question at any time during the webinar, and we'll do our best to get those into the flow of conversation. We've also saved time at the end to answer as many as we can get to in the time we have in our hour. We'll also be giving away a special giveaway from our sponsors at Microsoft Azure and Intel, $200 of Microsoft Azure credit on blazing fast Intel hardware to one lucky winner of our trivia question coming later in the episode. So stay tuned for that.
All right, thank you. Now, Sergio, take the stage, introduce yourself just a little bit, and then we will go and look at your slides, the presentation you have.
Okay. Well, first of all, thank you for the invitation. Okay, I'm Sergio. I'm a software engineer. I work at Brabant in the innovation lab with a couple of new technologies like chatbots and computer vision and this kind of things. Well, I'm going to show you my proposal for the contest.
That's great. And also, Sergio is one of those people who try reinventing themselves every few years. He started his career as an architect, and now he's a software engineer. But in his free time, he does AI-related projects, participates in these contests, etc. So that's really good. You're always expanding your areas of interest. You're always trying to move where your interest lies. So that's really awesome.
Yes, it's like a hobby, and I enjoy it a lot.
Yeah, and you were the finalist in both contests, right? In the previous contest, also you were one of the finalists, and here also you are. That's great. All right, let's get started.
It's an honor. Okay, let me share my screen here. You can see my screen, right?
Yep.
Yes.
Looks good.
Okay. Well, spatial computer vision Poka-yoke is the name of my proposal for the contest, and I want to start talking about the Poka-yoke term. Poka-yoke is a Japanese term that means mistake proofing. It is a concept that talk about avoid mistakes it was invented by Shigeo Shingo. He was part of the Toyota production system in the late 90s, I think. The main goal of this term is to avoid human mistakes in the production processes and these kind of things. And we can see Poka-yoke mechanisms and methods everywhere. Here I show you an AC cable that have a Poka-yoke mechanism in order to assure that you cannot plug the cable in the wrong way. No, it's an example. Right. Other examples, well, you maybe can think in some other examples, but for example, the USB shape is also a Poka-yoke. The SIM card from your phone is a rectangle with a corner cutting. To avoid, you can put the card in the wrong way. This kind of things. Some it's about security, some about mistakes or detections or this kind of thing. In factories, for example, when they have a big press, they have two buttons to activate the press to ensure that the hand of the operator never can be
wow.
in the press, and they put the buttons separately, and they need the two hands to press the buttons, and
Wow.
it's another Poka-yoke mechanism. Okay.
I'll give you examples where it is not followed. In many electronics, there is the 5 volt and the 12 volt connections. They are the same.
Those
and
barrel jack connectors you're
Yes,
talking
the
about.
barrel
Yeah,
jack.
the same. The two, I think it's like 1 centimeter barrel jacks. They are tricksy.
Yeah, you can, and if the hardware manufacturer has not made sure that it's not burning out, you can easily plug in a 12 volt and burn your circuit down.
Yes, I think I was the first person to blow up the original Oak D in this way.
I did too.
I
did too. High five. And so Oak D, the original Oak D had a 5 volt connection, and multiple people blew it out, and we obviously fixed it. We now you cannot do it, but it was a lesson learned through experience. I also wanted to point out that Toyota manufacturing process, so many good ideas have come out of it. For example, I think the word is Kaizen, which the word continuous improvement. I think the word is Kaizen. I might be pronouncing it incorrectly. That also comes from Toyota manufacturing process. It could be embedded in Japanese culture. I don't know about that, but at least Toyota popularized it. So really good stuff.
Yeah, it's the automation with a human touch is another one of the things that, another one of the phrases that came out of the famous Toyota production system as well.
Yeah, most of them born in the Toyota production system. Okay. Here is the real world use case I choose for my proposal. Is a factory from my hometown, Getafe in Madrid, Spain. Me in my job, I have to go to the factory sometimes, and I speak with the operators and the QA staff and some people from there. And they told me about the Poka-yoke methods and this kind of. I learned a lot. I was there. I was there to make a software application, but I learned a lot of the production processes and this kind of thing. And I choose the manual assembly lines they have to incorporate that kind of Poka-yoke methods. Okay. Okay. Well, one of the problems they have is the part picking. They have to assure that the operator took the correct parts. They have a lot of boxes, one near the other, and the parts are very similar, with a little difference in shape or in height, or a little difference, and there is a lot of sensorized systems that help the operator or the QA team to know that the operator is taking the correct part. Here in the right, we can see one of the systems that is a presence sensor when the operator put the hand inside the box. it sends a signal, and in QA they know that the operator choose the correct part or the wrong one. In my proposal, I want to remove all this sensoring and replace it with one sensor. Is the computer vision as a sensor. Okay. For this first problem, I used also the diff information from the OGD lit camera. Now it's very simple. The camera is placed on top of the picking area. And we know in the 3 axis we can follow the movement of the hands of the operator, and knows if he or she are taking the correct parts.
Yeah, and for people who do not know, OGD cameras, they can do, as Sergio had mentioned, they can run neural networks on the device itself. So you can train image classifier, an object detector, image segmentation model, and then load it onto the device. And the device is basically a camera. And and it also does depth analysis, right? So you can actually know that the part is at certain depth. So it's like sort of like human visual system, which uses both, we have stereo vision so that we can estimate depth, and we also interpret the scene. So both those things are there in the Oak camera. And that's one of the things that we ask the contestants to use. A good submission would use all the capabilities of the camera, including depth, to solve a problem in the manufacturing plant.
Yeah, and you can pick up your own Oak OpenCV AI kit at store.opencv.ai.
Yeah, this is the one I was looking for. And if you look at the distance between the two cameras, they were also designed to sort of mimic the human eyes. The distance is, I think, 72 millimeters, which is on the upper side of human visual system. Most of the people, the interpupillary distance between our faces is somewhere in that range, 65 to 70.
It looks a little something like this for those on the stream. It's pretty close, pretty close.
Yeah.
I have to say I love these parts of the show when Phil appears like a banner.
You're welcome. You got to give the people what they want.
Okay. A second.
I have one more. I have a question here about the. I noticed you're using specific little bins, and it looks like what did you make your little apparatus out of here? Because this is custom built, right?
Yes, it's custom built. It's a modular aluminum profile.
With those,
you can
the slots in there. Basically, can you just order those to, like, they'll cut to size for you, or did you just buy them in a bundle or something?
You can buy it at the size you want, and they have some screws, and it's modular. You can build whatever you want. It's not very expensive, and I built mine in 1 hour, and it's pretty simple. Yeah,
I love seeing the off-the-shelf parts being combined in new ways.
You can see it here behind me. It's it's the prototype. Okay, the second problem I saw in the factory at the factory. They have also to assure the correct part counting, and at the factory they have a very complex tables with lots of sensors, and and the operator spends a lot of time putting each part in its place at these tables before the assembly. And it's a lot of time that they spend only counting parts in the before start.
Okay, just so I understand, there is a table, the white table that you're looking at on the side, and all the parts are placed at specific location, and that's how the sensor inside would say that, okay, the part is present and now use the part. So you know that, okay, this whole setup is good, but you also need to spend a lot of time putting those parts manually into this on this table.
Yeah, that's correct. That's correct. And the two tables, in the left, you need, for example, 12 springs, and you have to put the 12 streams because the table well, the whole assembly cell needs a signal from the table that it's okay. All parts are in place, and you can start the assembly.
Right.
Okay.
And we should appreciate this also, right? I mean, it's not like now we have AI to solve this problem, but the people who designed these systems, they were very smart with the tools they had at that time available. They built something which is foolproof, right? So that you don't make mistakes. So we, even when we are excited about AI, we have to appreciate what people before us who did not have access to the technology that we have built something which is so robust, right? The manufacturing process.
Yeah, most of the Poka-yoke methods are very, very simple. With a color, for example, in the Lego kits, you have in the Technic kits, they have a lot of parts very similar, and they change the color. It's a Poka-yoke also, not for the color of the kit, but it's a Poka-yoke method also. For that, we can use with computer vision, we can use the same tables without all the sensoring. We can detect all the parts and count them without all the sensoring. And also we can count the parts not in a specific part of the table, or maybe in your hands, or near the assembly. And this is the second part of the proposal. Okay, and the third part is the most important one, because Poka-yoke methods try to avoid human mistakes, because an error in the production lines becomes a defect, a defective product at the end of the production line. And when you are for example, you are make water bottles, and it's water bottle cost you I don't know, a few cents. You can put a camera at the end of the line and throw away the 2 or 3 bottles that are not okay. The label are misplaced, or they don't have the cap. I don't know. But in this kind of assembly lines, one defective product is a big deal.
Yeah.
And is not easy to detect a failure or an error. If when you are building this kind of mechanisms, for example, this is a gearbox from well, a truck for the farm. I don't know how to say it in English. you know the John Deere vehicles.
A tractor.
Yeah, the tractor.
Yeah, like a tractor. It's not exactly a tractor, but okay.
Like a harvester or a combine?
Harvester
Yeah,
is the word. Thank you, Phil.
Yeah, you got to remember, I'm from farm country.
Thank you. Okay, you imagine that you are assembling this gearbox and you miss a little part of plastic. Nobody knows until the whole gearbox goes to the benchmark. They do a lot of testing in the. For example, they test the pressure of a liquid or something, and they detect a leak in that system, and they have to go back to the assembly line again, disassembly all the gearbox until they found that this part is missing. They correct the error. As they have to assembly again and go to the benchmark. And if they can solve or detect the error right when it occurs, it will be much more better than correct a defect. That's why it is the crucial part. Okay. And for that, we have the instructions, the manual from Lego for the kids. They have also instructions in the factory, very similar. All the assembly process in the factory and in the Lego kits are very similar.
Yeah, especially when, with Legos and with a lot of manufacturing processes as well. What's one of the awesome things about Lego assembly instructions, sort of like the best IKEA instructions, is that there's no words. They're all just purely presented visually. And because you're looking at the parts at the time you're doing it, it's pretty universal so long as you can actually see the parts, which I think is a really interesting aspect of this.
Yeah, in the Lego books, you have the 1-to-1 scale, and you can put your part.
Very smart.
Very smart. You don't need any word, and you only have to put the part on top of the drawing. And okay. For that, I need to build some very small models for each step of the process. I don't need a big model that solves all the problems. I need to build small models with much less image. I don't need thousands and thousands of images. I can build it with I don't know, 100 or 200 images. Okay, this is the last part of the problem I want to solve with my proposal. In the next slide, here I have my prototype. At the left, I have we have the work cell I built with this aluminum structure. And at the right, we have this Lego Technic kit with the instructions manual. At this point, I think in the contest, maybe there are two groups of projects or proposals attending to the relationship between the Oak Delight devices and the Lego kits. One group, I think, one group in which the camera looks or points from the Lego to the world, like autonomous robots or structures to hold the camera and move the camera. And I think there is another group in which the camera looks or points to the Lego. My proposal belongs to this second group. In my prototype, it's all about the assembly of the Lego kit. Like in real world, is the crucial part is the assembly itself. Okay. And here we can see. I don't know if. It's not starting.
Hey, you may have to like right click and have it like replay or something, or GIFs, right?
No, they are videos.
Okay, now it's playing.
Okay, yeah. I want to play the two at the same time, but
Also, I just pissed off half the audience by saying GIFs instead of GIFs.
Okay, the right view is from the camera on top of the structure I built. Okay. This only the preparation of the. We cannot play media. I'm sorry.
Can you open it in a different? Yeah.
Here we have the application that you have to set up. You have to tell the application where is each part, where do you put it, and you draw a rectangle that tell the application where is the box, and then you choose the range of the deep range. So you select the bottom limit and the top limit. Okay, and with that information. Okay. Here at the same time. This time it works. Here we are. I am using the media pipe model for detect the hand.
And this gives you the center of the palm, right? It's actually, isn't it doing palm detection?
Yes. It's the only the palm detection. We can I can calculate the three axes, the position of the hand in the three axes, and in this video we can see the deep estimation. You need to put your hand in the correct place at the three axes. But some of the sensoring systems and things like that, they fails when, for example, you put a piece of paper in the box, for example, or you put a globe or something. This way you detect the hand and you can measure the dip also. Okay, and finally, this is a work in progress. This is a video from my past participation in the last year.
OpenCV AI competition 2021. Yes.
Yes. That time I I was in the miscellanea category, and now I'm in the manufacturing category. I'm I'm in the correct place, I think. This is a correct part selection and part count verification. At the beginning, you can see that you need 4 green parts and 1 orange part. If you put one more that you need, they tells you that remove it.
So this is the detection is being done on a color basis, or is it? Did you actually train an object detector classifier?
No, it's you can do it with detecting only the color, but I built an object detection
Okay.
model.
Okay.
In the real world, at the factory, most of the parts are metallic, steel, or very similar in color.
Have you tried using those parts, those real parts, to see how the classifier works or the object detector works?
With this specific model, or
yeah, for this project, did you, if you go back to the previous slide?
A previous slide, sorry.
Yeah, even previous than that. Yeah, here, for example, the different parts, are you detecting the parts based on the location and the depth alone, or also identifying the part once it is in somebody's hand?
No, here you have to configure where which part have its box inside.
Got it.
But you can also build an object detection model and automatically put the correct part in the correct place.
Right. So no, but when somebody picks up the part, there's also a chance that there could be a contamination from one box to the other. Some part could have dropped into the other box. So it would be a good idea to actually verify what you have picked is correct one more time, right? Before.
With the part counting, I want to do that.
Got it.
You saw the parts and you detect the correct one and the wrong one in a second step. Okay. It's basically that I am doing here. For example, if you see the detections, there are 2 part 5 and 1 part number 6, and I am identifying each type of part.
Okay.
Yeah, it's a cool little. So, what did you use for this user interface here on this project?
I'm using TK Inter. It's a framework from Python. Mm-hmm. You don't have to install it. It's part of Python.
Yeah, no third-party dependencies. I like that.
Yeah. But I start coding in Python by myself. I'm not an expert in Python or in TK Inter, but you find a lot of documentation and a lot of forums on internet, and it's very easy to build. And in my application, they have a lot of methods linked. One from the buttons and this kind of thing is very simple to accomplish whatever you want.
That's great. What about the models? Are you training the models using PyTorch, TensorFlow, or how do you plan to do it?
Yeah. I'm not a machine learning expert, and for the models, I use a service from Microsoft Azure.
Okay.
It's called Custom Vision.
Custom Vision.
That the service choose for you the kind of model you build. You tag the images and then export right to OpenVINO
That's
from this.
I should know this better, but I'm still to try that. So this, do you need to also specify what should be the size of the model, where you're going to deploy it when you train this model, or it automatically determines that, okay, it cannot automatically determine, right? I mean, you have to tell it a little bit about your end use case.
Yeah, you have to choose between classification or object detection, and then you can tell the service if you want to use it for the edge or for the cloud, and it shows for you what kind of model fits better with your use case.
That's great. And what about the so we have the size of the model, we have the type of application like classification, detection, or segmentation maybe. Do they have segmentation as well?
No. You only have classification and object detection.
So they have two of those. And then what about the, do you also need to specify the data set? Does it matter how big a data set you are providing? What kind of model they choose? Does it depend on the amount of data you give them? Have you noticed anything?
I think no. You only have to upload and tag a minimum number of images. That's I think is 50. 50 if is the minimum.
Yeah.
And with that, you can build a first version of the model.
Okay. And could you repeat once again what exactly is the name of it's a Microsoft Azure service? Is it called Custom Training or?
Custom Vision.
Custom Vision. Okay.
It's
That's
part
great.
of Azure Cognitive Services.
Yes. Another banner for Onfill.
No, so that's really good because a lot of people who want to compete in our competitions, they feel that they need to be experts in computer vision, etc. But we have seen many people are able to use platforms, right? Like you used Custom Vision. There are other people who have used RoboFlow to train their models. As long as you have an understanding of what how to train these things and have a general understanding of how the training works and what do you do if you're not getting the right results, I think you can go far. You can go far in this competition as well as solving some problems you have in your projects, etc.
No, yes, exactly. I'm not an expert in machine learning. I build a software application, and I know that I need some models, but I don't know an extensive knowledge about machine learning and this kind of thing. I am a backer of the OpenCV courses last year.
Oh, wow.
I have all of them, and I'm become an expert this year.
That's great.
I hope so.
Unpaid product placement here.
Yeah, and for some reason I didn't even ask before this show whether you're familiar with the courses or not.
Sergio's over here doing your job for you, man.
That's great. We also have the Kickstarter campaign running if people are interested. OpenCV.org/Kickstarter. If you're interested, you can get both the courses as well as Oak Delight. So there is another question I had about this is, in the manufacturing process, right? In the manufacturing process, is there any chance you would be able to get some of this tested in a real manufacturing plant? Not in this one, but not for the competition, but after the competition, is there any chance you would be able to test it?
We at Brabant, the company I work for, we have an application similar to that in production right now at John Deere factory.
Oh, nice.
I cannot show you the
Of course.
the models, and it's much more complex and specific problems they want to solve. But yes, we can test this kind of approach at the factory. Yeah, it's very interesting, and you can talk with the operators and the QA team, and they give you a lot of feedback, and they have a lot of key points that they need to achieve, and you know about the process itself, and it's very interesting.
That's great. We can open up the questions to the audience if they have more questions.
Yeah, let's go ahead and do our trivia giveaway here. Are we done with slides?
Okay, I can finish that one.
All right.
Well,
let's finish this interesting video. I completely forgot about this. Sorry.
Okay, I think 2 minutes. Okay.
Yeah,
Yes.
we got time.
We have here a step sequence verification. You have to put some parts after another. We have here the correct part placement. When the system detects an error, they alert you. Here is another model to assure that the operator has the safety gloves.
So it's a classification model. When the gloves are detected, is that a classification model?
Yes, it's
okay.
Yeah. We can choose when to launch this model on top of the step, for example.
Yeah.
Some of the processes they have needs to manipulate the press, for example, or a screwdriver or a hammer, and they need to wear the glasses and
right.
the gloves. Okay, they have, this is an interesting use case, that they have a lot of parts that when they put it on the assembly, like this little black ring, when they put it correctly, you cannot see from the camera. You put it that way, and this small part is at the bottom of the gray part. For that use case, the system detects the part when the operator goes to place it in the assembly, and you make an object detection to.
Yeah.
And then a classification to tell if this part is present or not. And then when you have the object detection and part counting here also. And that is here some errors you can make. All these kind of errors, the QA team can tell you about all of this, but they have seen tons and tons of errors at work, and here you can for example stop the press, for example, if it detects hand in top of the assembly. Well, this kind of security concerns also. And that's the last one. Thanks all the audience for attending.
Yeah, no, thanks. This is great. Also, you did great on time. You're setting a great example for our next guests and previous guests. So we got about 10 minutes left, so we'll do our trivia giveaway. Go ahead and unshare your screen. Thank you, Sergio. So one of the things we do every week here on OpenCV Weekly Webinar is a giveaway. This week we will be, thanks to our sponsors at Intel and Microsoft Azure, giving one lucky winner $200 worth of Azure credits on blazing fast Intel hardware. The way this works is you and the Zoom audience will have a chance to answer in the Zoom chat window once I ask this trivia question. The very first person to answer it correctly on my screen will win the aforementioned $200 of Microsoft Azure credits on blazing fast Intel hardware. Please, if you have won in the last couple of months, do not answer, and let's try to spread the wealth around as much as we can. So earlier in the presentation, we learned about the term Poka-yoke, which comes from the Toyota Corporation. What was the name of the industrial engineer at Toyota who popularized this term? People, copy pasting doesn't count. Wait, I got Cal Marshall was right on it.
It's a good one. It's a good one.
Cal Marshall was right here. It's Shingyo Shingo. Shingo is the name. Shigeo Shingo. So congratulations there, Cal. Please send one email to phil@opencv.org, and we'll make sure that you get your Azure credits. So next, let's get to some questions. We have a couple here. Zach would like to know how do you alert the operator to errors in the current system? Does it like vibrate, or does it make noise? Is there anything like that currently, or is it just visual at this time?
No, I have also and some audio alerts.
So like a buzzer, does it go like?
I don't know if I can share a link, a YouTube link.
Yeah, sure.
Let me find it.
Post it in the chat.
Yeah, we can.
Is it the Price is Right horns?
We can take the next question while Sergio is looking for.
So will you be open sourcing the code for this project, Sergio?
In my GitHub profile, it's open.
So you're saying it's already there?
Yes.
That's great.
It's a work in progress.
All right. I'll drop that link here in the chat. There you go. So what was your inspiration to go down this path of the manufacturing? Obviously, it's part of your day job a bit, I guess. But what inspired you specifically for this competition and specifically for this project?
Well, when I was a kid, I loved the Lego kits. 30 years ago, I started playing Lego, and also the manufacturing area is very, very interesting, and I can approach these factories at my job at work. I see everywhere a lot of improves we can make at the factories with computer vision, it's computer vision is a technology that I like. I love play with it and learn every day.
I'm actually surprised why people don't utilize this to, these kinds of competitions to get more visibility, right? Like we did a competition with my, Learn OpenCV blog also, where we asked people that there's a competition for blog writing. Now, if I was a new startup, or if I was a person looking for visibility, I would latch onto that and create, a very good blog post talking about things, right? And I would, it's free publicity, right? You don't get this kind of publicity often. The same thing is true about this competition. Look at Kotick Tigers. They were a small company. Last year, they participated in the competition. They did a fabulous job. They won the competition. And now a lot of people know them. A lot of people, even at Microsoft, Intel know them. So it opens up doors for people, right? It opens up a lot of doors. And you'd be surprised, it is tough, but not very tough to shine in these competitions. If you're committed to it, you will do very well, right? At the very least, especially in our competitions, we try to feature people when it's not like, oh, we just focus on the top 3, right? We want to feature people who are doing their best and who have something interesting to show. Even if they don't win anything, we try to make sure that they get visibility, right? So I'm sometimes surprised that more people, we got a lot of submissions. I agree that for this competition also, we got a lot of submissions, but still, I would expect double the number of submissions usually. It's a great platform. And also you get free help. If you want in your project, if you want something, we are at your disposal. I'm pretty certain that when you go to Luxonis Discord channel for help for OpenCV AI Kit, they are helping you out, right? Whatever question you have, they will help you out, and they help you out regardless. But because you're part of the competition, there is extra, pressure that, oh, we have to make sure that we answer the questions and make sure that everybody gets help. So those are 2 reasons I think people should be doing these competitions. Startups or individuals who want to get visibility and also experience, right? Like Sergio, it's about initiative, right? Even though he doesn't have a background in AI, he did not stop that, oh, I'll gather all the background. Let me just jump in and learn in the process, right? While I'm in the process, you learn and you get a lot of, there is a deadline and it puts pressure on you. So you quickly learn a lot of things, which without a deadline will just, it will just stay there and you will never get to it.
Yeah, there's, the metaphor you could use, it's not necessarily being thrown in the deep end, but it's being thrown in the medium end.
Right.
There's just enough pressure that you're pushed to continue doing stuff, but it's not so much pressure that it's keeping you up at night. At least I hope not. So another question from me is, do you have any advice for your fellow competitors here in the contest?
Sorry?
Do you have any advice for your fellow contestants here in OpenCV Spatial AI contest?
I don't know. I always think that maybe you don't finish your project, but the deadline. And when I work as an architect, I participate in a lot of international competitions to win the construction of a building or something like that. Sometimes you don't get with the whole project at the deadline, but if the process that you have to enjoy. You learned a lot. When you win and when you lose, if you participate and you work every day, or when you have some 2 hours. I don't know, a week. I don't have a lot of time in my everyday to work with that, but I enjoyed it a lot, and I think that the process, enjoy the process is the most important thing, and learn a lot.
It's all about the journey, not the destination, folks. Good advice from Sergio. We're up on time. Satya, you want to take us home? We've got a couple of big things going on currently. We've got the deep learning with TensorFlow and Keras Kickstarter is still ongoing. OpenCV AI game show is coming up real soon. What else we got?
Well, yes. So I just want to reiterate the Kickstarter campaign. We still have a few days to go on the Kickstarter campaign. The price of Oak Delight on the Kickstarter campaign went up by $10, but it's still at $109 compared to $149, which is the retail price on the store. So if you're interested in courses, all other courses are also discounted. So if you're interested in our courses or Oak Delight, please visit the Kickstarter campaign, which is opencv.org/Kickstarter, and back us. It's also possible to just get Oak Delight by backing $1 so that you become a backer, and then you add Oak Delight as an add-on. Second thing, very exciting thing coming along is OpenCV AI show. It is going to be very, very exciting. If everything goes right, the scheduled date is March 17th in this time. So we will have a game show where we will have 3 very interesting people on the show, and we will ask AI questions to them. And eventually the game show will evolve, but we'll see how it goes. It's going to be fascinating, in my opinion. I have seen we have actually created a virtual set, which our friends at Light Twist have created for us. And it's still going to be Zoom, but it's going to be very interesting. First time in history, somebody's trying something like this in the AI domain. So so please, there is a website also we have. Do we have it up?
Yeah,
Phil?
it's a little bit bare bones right now, but you can sign up at opencv.org/game show, all one word, and you'll be the first to know when we have new information, which is going to be coming fast and furious over the next couple of weeks. We'll be announcing and introducing our host, as well as the contestants and the virtual set. You won't want to miss it.
Yes. So that's going to be very exciting. And finally, this thing is heating up. Our OpenCV Spatial AI competition, which is sponsored by Intel and Microsoft Azure. So we will present more and more, in coming months about that. So
yes, the deadline is coming up on April 1st, as well as we've got a couple more teams that will be doing presentations over the next couple of weeks right here on OpenCV Weekly Webinar.
All right. So that's all I wanted to cover. And so thank you, everybody. Thanks, Phil, for managing this webinar. Thanks a lot, Sergio, for coming up and presenting. I know, this is, we are more than halfway into the competition, but still it is part work, and it takes some courage to show, partially done work, but we will always encourage people to show whatever they have, because it shows the process, right? And thank you for showing what you have done so far. And I wish you all the best for the competition.
Thank you.
Thanks. And thanks a lot for our audience. It's great having you here every week. We hope to see you again next week. Thanks.
That's right. Same bat time, same bat channel, 9 a.m. Pacific, right here.
All right. Thanks. Bye.
Bye.